And finally, your last exercise for this section. I want you to create this function, show primes, that takes a limit and shows all the prime numbers up to this limit. So here are the prime numbers that we have up to 20. We got 2, 3, 5, 7, and so on. In case you don't know what's a prime number, let me give you a brief explanation. So in mathematics, numbers can be prime or composite. A prime number is one whose factors are only 1 and itself. So it cannot be divided evenly into another number. Let me give you an example. Think of 12. What are the factors of 12? Well, we got 1, 2, 3, 4, 6, and 12. These are the factors of 12. So when we divide 12 by these numbers, we won't get any remainder. The remainder will be 0. So we say 12 can be divided evenly by its factors. Now 12 is a composite number because it has many factors. A prime number, in contrast, has only 2 factors. It's 1 and itself. Here's an example. So we got 11 here. The factors of 11 are 1 and 11 itself. The same is true for 13. It can only be divided evenly by 1 and 13. So go ahead and create this function. You will see my solution next. To implement this function, we need a for loop that starts from 2 up to this limit, because the first prime number is 2. So for let I, we set it to 2, as long as I is less than or equal to limit I plus plus. Now for each number, we need to check to see if this number is prime or not. So we need another loop here that starts from 2 all the way to the current number, that is I. With this nested loop, we can see if I has a factor other than 1 and itself. So let's define another for loop. Now what should we call this other loop variable? We cannot call this I because we have already defined I here. So one way is to call this J, but someone reading this code, they don't know what is I, what is J. It's confusing. So always pay great attention to the name of your variables. What I is essentially representing here is a number. So the outer loop is for iterating numbers from 2 to this limit. So let's call I number. We press F2 here and rename it to number. Now what is this inner loop for? That is for finding the factors of that number. So instead of calling the loop variable J, we can call it factor. So factor, we set it to 2. As long as factor is less than this number, we want to do factor plus plus. Let me expand this a little bit so you can see. All right, now, if this number can be evenly divided by its factor, so if number modulus factor equals 0, that means this number has a factor other than 1 and itself. That's why I have not included 1 in this loop, because of course, every number can be divided by 1. For the same reason, I have not included the number itself in this loop, because again, we know that each number can be divided by itself evenly. So in this inner loop, we want to see if we have a factor other than 1 and the number itself. So if we do, that means this number is not a prime number. So basically what we can do here is declare a variable, call it is prime. We can assume that this number is a prime number, but if this condition is true, then we need to set is prime to false. Also, if we get to this point, there is really no need to continue this loop, because let's imagine we want to display all the prime numbers from 1 to billion. Now in this inner loop, as long as we find a factor for this number, that means this number is not a prime number. So there's really no need to continue running this loop, because this is just wasting our computer's processing power. So here we can add a code block, put is prime here. If we get to this point, we can use the break keyword to jump out of this loop. Okay? Now, when we get to this point, is prime is either true or false. If it is true, we log this number on the console. Save the changes, we get this result, beautiful. If we pass 10 here, we get all the prime numbers from 2 to 10. Now here's another challenge for you. Earlier I told you about the single responsibility principle. We want to have small functions, each function responsible for a single task. So I want you to modify this code, extract a new function, make sure each function is small and responsible for a single task. So pause the video. When you're done, come back, continue watching. So if you look at the lines 7 to 11, all we are doing here is checking to see if a number is prime or not. This logic does not necessarily have to be part of our show primes function. We can have a separate function called isPrime that takes a number and simply tells us if this number is prime or not. Then we can use this function inside of show primes function or somewhere else. So it's a reusable function. It's a reusable piece of code. So I'm going to extract all these lines, move them to our new function. Now we can make this code cleaner and more elegant. So if we get to this point, instead of breaking from the loop, we can simply return false. In other words, there is no need to break and then return isPrime. We can do a shortcut here. So if we get to this point, we simply return false. That means we don't need to set isPrime to false. We don't even need to declare isPrime. So we run this loop. We try to find a factor for this number. If we find a factor, we immediately return false. Otherwise, if we get to this point, that means we didn't find any factors for this number, so we return true. Also, we can get rid of all these curly braces because our for statement, our for loop has a single statement, and our if statement also has a single statement. So let's get rid of all these extra curly braces getting in the way, annoying me. Okay, that is better. Now finally, in show primes, so here we have only a single loop. We are iterating the numbers from 2 to this limit. We simply call isPrime function and pass our number. If the number is prime, we log it on the console. This also means we don't need these curly braces. And here's the end result. With these changes, now we have two very simple functions. If you give this function to the dumbest person in the world, they won't understand it. Also, we don't have nested loops. Generally speaking, nested loops are a bit hard to understand. So whenever you have a nested loop, that's probably an indication that you can extract the logic in the inner loop and put it somewhere else in a different function. So that brings us to the end of this section. I hope you enjoyed the materials and thank you for watching.